What if I told you the electric vehicle industry just hit its biggest breakthrough in decades, and it could change everything you thought you knew about EVs? Toyota's CEO just dropped a bombshell, a rare earth free motor that's ready to roll by 2026, threatening to upend the entire market and break the chains of scarce expensive materials. This isn't hype, this is a revolution in motion, and you need to hear it now. If you want to stay ahead of the curve, hit that like button and subscribe. Trust me, this story is just getting started. Beneath the blinding lights of the Tokyo Auto Salon, something unthinkable was unfolding. No teaser campaign, no social media countdown, just a single man, Koji Sato, CEO of Toyota, stepping onto the stage with a blueprint in hand and a calm seismic message that sent shockwaves through the global auto industry. We no longer need rare earths to power electric vehicles. Not we hope to, not we're working on it, but we already did it. A rare earth, free EV motor, real production ready, and rolling out in Toyota's 2026 lineup. The room went still. No applause, no smiles, just silence, because in that moment, everyone watching understood what had just happened. The rules of the game had changed. EV suppliers in Europe panicked. Auto analysts in Detroit scrambled to confirm. Wall Street algorithms tripped over themselves. In under 30 minutes, Tesla's stock dropped 4.1%. Rivian and Lucid followed. Toyota up 7%, its biggest single-day gain in over a year. But the spike wasn't just about market share. It was about control. For the first time in decades, an automaker had severed its dependence on the most strategically vulnerable supply chain in tech, rare earths. Behind that simple announcement was a truth far more dangerous, one that governments, militaries, and energy alliances had been whispering about for years. Rare earths weren't just scarce, they were a geopolitical weapon. For decades, rare earth elements like neodymium, dysprosium, and terbium were treated as technical necessities, ugly but unavoidable. They power permanent magnet motors, which dominate the EV market for their unmatched torque and efficiency. No one dared challenge them. Every major car maker, Tesla, Ford, Hyundai, BYD, relied on the same fundamental recipe, a recipe written in Chinese because 87% of global rare earth processing is controlled by China, not just mined, processed. That means even if the US, Australia, or Canada finds new rare earths in their soil, they still need to ship it to China for refinement. That's not a market, that's a monopoly, and it's a monopoly that's growing more volatile by the day. Since 2020, rare earth prices have surged over 230%, spurred by trade wars, nationalist export controls, and rising EV demand. In 2023, China threatened to limit gallium and germanium exports. Rare earths were next. The US Pentagon labeled the dependency a critical vulnerability. Japan called it an economic gun to our head. The EU, a sovereignty crisis in slow motion. This was the trap. Everyone knew it. No one escaped it until now. What Toyota just revealed isn't just a clever workaround. It's the engineering equivalent of slipping out of handcuffs while the world wasn't looking. And the secret. Ferrite, common iron oxide, cheap and abundant. A material engineers once dismissed as too weak for high-performance EVs. But buried inside Toyota's R&D powertrain lab, a silent revolution had been brewing for 8 years. Using ferrite wasn't enough. The challenge was to make it sing. Toyota's engineers redesigned the magnetic circuit from scratch, every coil, every stator tooth. Then came a breakthrough, a proprietary iron-based alloy tailored through thousands of AI simulations to find the perfect balance between conductivity, temperature tolerance, and magnetic flux density. They didn't just remove neodymium. They replaced it with something new. The result? A motor that's within 3% efficiency of traditional rare earth models, but at 1/5 the cost. And it isn't limited to concept cars or test benches. This motor can be produced on existing lines using minor modifications to Toyota's current hybrid and EV assembly system. No billion-dollar factory overhaul, just a software update, a tooling swap, and go. In engineering terms, it's clean. In strategic terms, it's nuclear. Because now Toyota holds a key no one else does: independence. Not just from China, but from a global tech ecosystem addicted to fragile supply chains and toxic extraction methods. This isn't just a story about cars, it's a story about autonomy, leverage, and timing. And Toyota picked the perfect moment to strike. Just as Western governments were pouring billions into rare earth mining subsidies, just as rival automakers were locking in long-term supply contracts with Chinese refiners, Toyota stepped out of the shadows and said, "We don't need it," and the world froze. What else have they been hiding? How long have they known this would work? What happens when other automakers try to catch up and realize they can't copy the alloy or the patents or the 8 years of internal data behind it? Because this isn't just a new motor, it's checkmate. And here's the part no one saw coming. The breakthrough wasn't built on rare earths at all. It came from a material the industry had written off. Something so common, so overlooked, it bordered on laughable: ferrite. They said it couldn't be done. That ferrite magnet's cheap, abundant, crude, would never match the power of neodymium. That rare earths were the cost of admission to the EV race. But behind closed doors at Toyota's Advanced Powertrain Lab, the rules were rewritten. In a climate-controlled facility outside Nagoya, engineers stood around a humming prototype that shouldn't have worked, and yet it did. The key: heat. Ferrite magnets typically break down under high-temperature loads, making them unreliable for the punishing demands of electric propulsion. But Toyota's team cracked the code. Using a ceramic nano-coating process lifted from aerospace plasma shielding, they stabilized ferrite performance up to 180 degrees Celsius, a threshold once thought impossible. Suddenly, what was once a lab curiosity became roadworthy. But stabilizing ferrite wasn't enough. To replace rare earths outright, Toyota needed torque and lots of it. That's where the magnetic circuit came in. They didn't just redesign the motor, they reimagined the field lines themselves by reshaping the magnetic flow path using AI-driven coil saturation modeling. They turned a low-density material into a high-efficiency weapon. Traditional rare earth motors rely on brute magnetic force. Toyota's relies on precision geometry, a difference of philosophy, not just chemistry. Cooling presented the next barrier. In conventional EV motors, heat disperses via simple liquid jackets or passive fins. But this motor borrowed from jet turbine tech using an induction-cooled rotor with micro-channel heat exchangers, a system derived from fighter jet alternators. They managed to slash core temperatures by 22%, keeping performance stable across aggressive driving profiles. Even the copper wiring got an overhaul. Tex-B, copper. Instead of single-layer windings, Toyota developed a dual-layer counter-twisted copper layout that meant faster energy transfer, tighter electromagnetic field generation, and denser torque curves, all while fitting inside a motor casing 15% smaller than its predecessor. And finally, the brain, the inverter. The shelf units couldn't handle the low field strength of ferrite magnets, so Toyota built one from scratch, a custom silicon carbide module with predictive field compensation, able to dynamically reshape current pulses in real time. The result: a system that mimics the punch of neodymium without needing a single atom of it. But here's the real twist. This wasn't an overnight miracle. It was a deliberate long game, 8 years in the making. While the headlines obsessed over Tesla's 4,680 cells and Biden's lithium breakthroughs, Toyota quietly poured $14 billion into next-gen electric motors. It wasn't flashy, it wasn't public, but it was strategic. Internal memos dating back to 2018 reveal the intent clearly: build for disruption, build for independence, build for when the world decouples. This wasn't just engineering foresight, it was geopolitical calculus. Toyota saw the writing on the wall long before the West acknowledged it, that critical minerals were a chokehold waiting to tighten, and that relying on China, the gatekeeper of 87% of the world's rare earths, was an unacceptable risk. So, while rivals chased range anxiety and battery density, Toyota drilled into motor independence. They mapped out every vulnerability in the EV supply chain, from mining and magnets to shipping bottlenecks, and began removing dependencies one by one. This wasn't about PR, this was about survival. Japan's government quietly backed this play through hefty grants and deep tech subsidies. The Ministry of Economy, Trade, and Industry coordinated with Toyota on mineral security, because for Japan, this wasn't just about selling cars. It was about ensuring that when the geopolitical storm hit, when trade routes faltered and export bans dropped, the nation's largest automaker wouldn't flinch. And now the moment has arrived. The storm is here. Rare earth prices have spiked over 230% since 2020. Export restrictions have tightened. And the EV giants, the very companies that once led the pack, are now exposed. Tesla's prized 4,680 motor still contains trace neodymium, confirmed by independent teardown reports. Its factory in Texas can innovate around form factors, but not around fundamental materials. The next GAN Roadster, the Cybertruck, they still need rare earths, which means they still need China. Bide even more vulnerable. Despite their massive vertical integration and domestic dominance, their Blade series and E-Platform 3.0 architectures still run on permanent magnet motors sourced from the same rare earth pipeline. Their entire scale, their unbeatable price point, depends on access to materials that are no longer secure. Rivian, Lucid, Volkswagen, all still tied to the magnet crisis. None have a viable path off the dependency cliff. Toyota's move didn't just shift the narrative, it detonated it. Because this isn't just an innovation, it's a total reset. One company, long dismissed as too cautious, too slow, has just leapt an entire generation ahead, not by chasing range or acceleration or even autonomy, but by eliminating the one thing no one thought could be eliminated. And now the world is scrambling to catch up. They thought they had decades of dominance left. But within weeks of Toyota's announcement, the landscape began to tilt. Ford executives scrambled to review existing motor contracts. Volkswagen convened emergency strategy sessions behind closed doors. Suddenly, the entire industry faced a brutal ultimatum: evolve or be erased. Governments weren't far behind. The European Union accelerated Horizon Europe's funding lines, funneling millions into rare earth, free motor research, now seen not as an alternative, but a necessity. What had been considered niche science was now the new front line of energy independence. Meanwhile, India launched a rare earth exit strategy. Australia pledged to retool its mining focus, and Brazil green-lit tax breaks for domestic ferrite motor manufacturers. The map was redrawn in real time, and then came Toyota's masterstroke: open patent licensing. On the surface, it looked generous, a nod to global collaboration. But insiders knew better. By controlling the core standards for this new class of motor, Toyota wasn't just selling cars, it was laying down the architecture of an entire ecosystem. With each license granted, their influence deepened, their standards adopted, their supply web cemented. What stunned analysts most was how fast the balance of power shifted. Nations with no rare earth reserves, once written off in the Evray, suddenly became prime locations for motor manufacturing. Eastern Europe, Central America, even parts of Africa, all now back in play, and the silence from Tesla deafening. In Beijing, red flags were flying, and not just the symbolic kind. For decades, China had been the unchallenged king of rare earth magnet production, feeding the entire EV world through a tight chokehold. State-backed giants like China Northern Rare Earth had entire economies dancing to their supply timelines. But Toyota's ferrite motor didn't just loosen the grip, it snapped the chain. Across Chinese tech forums, analysts didn't mince words. Strategic catastrophe, supply line decoupling in real time, a threat to national leverage. Words once reserved for geopolitics were now being used for car parts. The financial hit was swift and brutal. Initial predictions estimated that if Toyota's motor design reached scale, China could bleed out $35 billion annually in rare earth exports. Not just EVs, wind turbines, defense, satellites, all sectors tethered to magnet exports were now in play. Suddenly, Japan, not just Toyota, was being viewed as a strategic counterweight to Chinese dominance. In Washington, Pentagon briefings began referencing Toyota's motor as a case study in asymmetric industrial advantage. Brussels cited it in trade strategy memos. Tokyo knew what it had done, and it wasn't apologizing. EV startups, many still clinging to rare earth-based motor designs, suddenly looked like relics. Pitch decks that boasted neodymium torque superiority now felt like death sentences. Investors pivoted overnight. Some pulled out entirely. Others demanded motor redesigns within quarters, an engineering impossibility for lean operations already burning through cash. A new wave of venture capital emerged, targeting magnet innovation over mineral extraction. The age of speculative mining was giving way to smart materials. It was no longer about digging, it was about designing. Efficiency would come from labs, not landscapes. And beneath it all, Toyota's move had triggered a silent purge, one no one saw coming. Dozens of AVE startups from California to Shenzhen quietly halted development. Some pivoted, most folded. Their roadmaps were built on a material assumption that no longer held. The industry hadn't just shifted, it had shed its skin. And Toyota, it hadn't even released the car yet. But the aftershocks weren't confined to boardrooms or bankruptcies. The shockwave Toyota set in motion will hit consumers faster and deeper than anyone expected. Cheaper motors alone could slice $1,200 to $1,800 off the sticker price of every EV. That's not a gimmick, it's cold, hard economics. By removing rare earths from the equation, the motor's manufacturing cost plunges, making EVs accessible to millions who once saw them as luxury toys. Suddenly, affordability collides with ambition, but price is just the surface. These ferrite motors generate less heat, dramatically extending their lifespan. Without rare earth magnets degrading under thermal stress, motors last longer, drive smoother, and demand less from costly cooling systems. Owners will soon notice fewer repairs, fewer trips to the shop, and more miles without a hiccup. Maintenance costs fall too. Ferrite's durability means fewer moving parts wearing out and no rare earth decay that silently erodes performance. The old days of expensive replacements and complicated servicing could become relics. EV ownership might finally edge past the convenience and reliability of combustion engines, a historic tipping point. And the environment, the difference is staggering. Ferrite magnets bypass the toxic chemical cocktail unleashed by rare earth mining. No more toxic wastewater leaking into rivers. No devastated landscapes poisoned by extraction. This is not just cleaner tech. It's a cleaner planet. Consumers who once overlooked the hidden cost of their vehicles may soon demand rare earth, free badges with the same fervor they once sought lead, free gasoline. Sustainability will become a selling point, not a slogan, but Toyota's vision doesn't stop at passenger cars. Their rare earth free motor is already slated for forklifts, drones, and even wind turbines, sectors long trapped by the same material constraints. Lexus and Toyota commercial fleets will debut the technology in 2026, showcasing durability and sustainability on every street and warehouse aisle. The company's e-Pallet urban mobility platform, a futuristic electric pod designed for autonomous transit, now boasts a powertrain that's not just efficient but truly sustainable. Conversations with Kawasaki Heavy Industries and Yamaha hint at marine engines and motorcycles embracing the ferrite revolution. This isn't a one-off innovation. It's the backbone of a vast, interconnected rare earth, free energy ecosystem. The full weight of Toyota's breakthrough now threatens to topple China's grip on future tech materials. Rumors swell that the US Pentagon is already negotiating to adopt this motor design for its fleet of defense logistics EVs, seeking independence from unpredictable supply chains in a world edging toward conflict. Inside Tesla, whispers of ferrite motors have sparked urgent discussions. Engineers and insiders are probing feasibility, their silence speaking volumes about the pressure to adapt or risk obsolescence. Even the company long hailed as EV royalty faces a new reality. The game has changed, and the race is far from over. Imagine a future where batteries, motors, and vehicles shed their dependency on rare earths completely, where supply chains are resilient, prices fall, and environmental harm retreats. This future is no longer science fiction, it's on the horizon, a plausible tomorrow crafted by the quiet genius of Toyota's engineers. In the end, Toyota didn't just reinvent an electric motor, they may have reinvented global power itself. The silent hum beneath their vehicles now echoes through boardrooms, factories, and capitals worldwide, an unmistakable sound of a new era beginning. If this blew your mind, imagine what's coming next. Don't just watch history, ride the front wave of it. Hit that like button, subscribe, and turn on notifications because the next disruption is already on its way, and you'll want to be the first to know.